Welcome to online classes on continuation of AC motors for 5th semester C18 scheme E503 in 3-phase induction motors. Last class we have seen the circle diagram of induction motor, some part. Now we will complete the circle diagram in step by step. Okay. So, let us recall what we have seen in previous classes. What is a circle diagram? It is a graphical method to analyze the performance of a given 3-phase induction motor, just like it is a horoscope of machine. Before going to install or apply the load on a new machine, as an electrical engineer, we have to check it. What is its efficiency? How much it can generate, produce a starting torque, and how it changes its speed, that means slip, changes based on load. What is the maximum torque and what is the power factor, and the power factor changes based on load also. So, we want to know before going to practically apply the load. Hence, so we require to perform few tests before going to apply our actual load. What are the tests we are going to conduct on this machine? Only we are going to conduct two tests. One is the no load test, another is the block rotor test, and in small test also VI method, the stator resistance method, calculated by injecting the some amount of the DC voltage and calculating the what is the current. That voltage by current will gives the resistance value. Okay, how to do these experiments already we have seen in previous classes. At the same time, we also calculated problems based on some formulas. Okay. So, these formulas, what is the formula? Torque is directly proportional to the S into E square into R2 by, so R2 whole square plus G of X2 whole square under root something. Okay. Slip is equal everything. So, instead of knowing these mathematical equations, to use up these mathematical equations to know the starting torque, efficiency, slip, power factor, maximum torque, etc., etc. No need to remember this all laws. I can know its total characteristics, performance at any given load or slip. These all values by simple measuring the length or angle in a given circle diagram. Okay. So, this is Jataka Chakra. So, based on this one I can know, so when you are going to marry and when you are going to settle, everything I can predict it, but only in that case prediction, but in this case I can get 100% the actual values. Okay. So, what we have seen in previous classes, let us say this is the total circle diagram you can see here. So, do not panic dear students, I can tell you one by one step. This is the total circle diagram. Okay. So, let us know in this class total circuit diagram. In next class we are going to do the one practical example by what is the by taking the values of open, that is the no load test values and short circuit test values practically. Okay. So, now let us see it. Okay. So, what is a diagram giving the locus of the current drawn by the induction motor is referred as a circle diagram. That means our aim is to know that I1 is the stator current. That is the current which is given to the motor, that is taken from the supply. This current magnitude and its a power factor changing based on the slip. That slip means that changing the rotor speed. How the rotor speed changes? Under no load condition, the rotor will rotate under normal condition with a small slip. Okay, so that is the rated RPM may be 1440 RPM per a 4-pole machine. Okay, synchronous speed is a 1500 RPM. Our rotor is running at 1440 RPM. What is the reason? So already we have seen in synchronous motors, so synchronous speed and rotor speed are equal, but in case of induction motor, so we never reach our rotor speed synchronous speed. Okay, that is the main difference between the synchronous motor and synchronous the induction motor. At the same time, you can observe one thing also, while applying the load on rotor in case of synchronous motor, the speed will run at the same constant speed only, that is at synchronous speed only. But whereas in our induction motor, if adding the some load, automatically the rotor will slowly, it will reduce its speed. That means from at no load it is running 1440 RPM. If added the some amount of the load, for example 2 kgs of spring load, you are going to apply this load in our laboratory. If applied the 2 kgs on our motor, the instead of running at 1440 RPM, now it will run at 1420 RPM only. That means 20 RPM reduced due to the load. And at the same time, if you added the further 2 kg loads, then the speed will reduce to the 1400 RPM. That means what is happening? The slip increasing. So 1440 it is a slip, and 1420 another slip, and 1400 another slip. So during this changing speed, during this changing slip, how the I1, the stator current changing? So that can be represented in a semicircle. So that is known as a circle diagram. So this method aims at the plotting the locus of input stator current I1 for various values of slip. Okay, so what is the I1? As we know that I1 is a stator current, it is a vector sum of no load current I0 plus I2 dash, that is the rotor current referred to the stator current. Based on that, we are already learned in the previous class. Okay, let us will complete this our circle diagram. Okay, now the dear students, so this is the topic today we are going to cover. At the same time, before going to our topic, I am sincerely thanks to the materials contributed to our electrical engineering purposes. Okay, courtesy to all authors. Now, so in previous classes we have discussed how to draw the circle diagram from no load and block rotor test and draw the performance curves of induction motors. Today objective is, on completion of this topic, the student will be able to know that find out all the required values of induction motor from circle diagram. After drawn the circle diagram, now you have to find out how to know that what is the maximum torque, what is the slip, what is the efficiency, what is the rotor copper losses, what is the stator copper losses, what is the constant losses. Okay, so these are we are going to find. Now this is the total circle diagram you can observe in our textbook. Okay, this can be gives at a glance the total history of motor. That's it, the prediction of our induction motor. Okay, let us do it. Now what we have seen in previous class, So, we have seen that previous classes. So, we taken the x axis is a reference axis and y axis as a voltage axis. Okay. In this case, all applied voltage V1 is drawn vertically. Okay. That is the all values taken reference with the voltage only, vertical axis only. Okay. All the vertical distances represent the power components of currents. Okay. So, we will see it. Now, what we have seen, so based on the no load test, we found that so I0 and cos phi 0. Okay. We have known that from the ammeter I0, from the voltmeter V0, from the wattmeters we know that W0. Based on power, voltage, current, I can found what is the cos phi 0, the power factor under no load condition. Then phi is equal cos inverse of this value, I am going to get the angle. Now, in this case, I am going first case, I have known that I0 no load current at an angle of phi 0. The first step, I can draw this line. Second step, I am going to write it from this is the OC test, no load test. This is a black rotor test, that is a short circuit test. So, in this case, I am going to get it I know from this is called ISN at angle of phi SC. What is this one? So, that means I converted short circuit current. So, from the SC test, black rotor test, I know the VSC and ISC and WSC. So, here what is happen when the rotor is blacked and we given the supply to the motor, whatever the power is consumed, it is evaporated in the form of copper losses. Okay, because the mechanical losses is 0 and some amount to the iron losses. So, this will give the total copper losses. Now, this is we are given that this voltage is only 10 to 20 percentage. Okay. For example, our motor is 440 volts. So, in this case, we are going to nearly 80 voltage we are given, low voltage is given to in this case. Okay. Then current will goes the full load current. What is that is the full load current. Reduced voltage, rated voltage current is given. At that condition, our meter will shows some power. That means with reduced voltage, it is giving the power. Suppose I given instead of 80 volts, if I given the 440 rated voltage, what is the power consumed by our motor? We are going to calculate, that is the calculation of ISN. So, what we have seen previous classes? So, we have seen ISN is equal to, so whatever you calculated, this is a wattmeter reading, ISC into what is the value, that is equal rated voltage, that is equal 440 divided by, so here VSC, what is the voltage you are going to get it, this voltage VSC. So, we are going to get that is equal current ISN. So, we taken this is the value. Okay. So, this already we have seen in previous class. Now, from the 1 and 2, so we will draw one thing. Okay. So, first what we have done, so we take this one, this is so we take in the I0 at magnitude of 0 to A, I write the I0. Okay. 0 to A represent the no load current magnitude at angle of phi 0 with reference to the y axis. Okay. Let us assume that may be 76 degrees centigrade, degrees from y axis. So, we taken the 70 degrees by using the protractor, and magnitude with the scale I taken the 0 to magnitude, that is I0. I taken the scale also. Last class we have seen 1 centimeter is equal to 1 ampere, or we taken the 5 amperes is equal to 1 centimeter. So, proportionate scale you should take it. Now, let us assume here I taken the 1 ampere is equal to 1 centimeter. So, based on no load current, so I taken the magnitude 0 to A is the magnitude of no load current at an angle of phi 0. Okay, this is from the no load test. Now, what is the second step? In second step, you are taken the short circuit current. I know the 5 SC black rotors, and I know that that is a value 0 to B magnitude ISN. Okay, I taken that ISN. So 0 to B we taken it. Now he got it, the magnitude 0 to B and angle of 5 SC from the black rotor test. Now second case, third step, now you know the A and B, two vectors at different angles. Now A and B join it. Okay, so A and B join the third step. Now this will indicates that is the output line of the motor. Okay, so output. So what are the output, then you just here output of the machine. Now we know that A and B, we know that. So that is means OA plus AB is equal to OB. That is the vector sum of OA and AB equal to the OB. Okay, last class we have seen. Now in this case, now we draw the bisect the AB, or you can write the bisect the AB line. Okay, output line bisect in the next step. So what? So you know the, by taking the compass, you are bisecting the AB line at the center and join the line. Now this bisector so cuts the line near to the reference value. Now here what will happen? So OX is a reference, but I know that, so here distance from A to X value, reference value, what is the vertical, that component? That can be, I can write the, I can draw the one line parallel to the reference OX from A point. Okay, that is indicates that this is a indicates that that's a constant losses, or we can say the fixed losses. Okay, what is the fixed losses here? That is the mechanical losses and iron losses. Automatically copper losses, it changes based on the load current. Okay, now A and vertical distance from A to X reference axis, that indicates the constant losses. That's why these losses are the uniform. Okay, now this bisector cuts on, or so the, that is the baseline, you can say the baseline. So baseline, you can write the D represented by the D. One point you can represent the D. Now based on the D, so AD, that is a parallel to the OX, and AD represents the reference line or baseline, and OX is the reference line, and this bisector cuts the our AD at C, on C as a center, from AC as a radius, and AC is equal to the CD. Then by taking the compass from AC as a radius, you can draw the one circle that will meet the A and B on a semicircle. Okay, now you can observe that, dear students, A, B, D are on the circumference of circle, 3 points. Okay, so this is another step. After bisecting, and draw the AD as a baseline, and you are going to get the C as a center, from the center AC as a radius, and draw the one semicircle. Okay, so this is last class we have seen. At the same time, so now you can draw the one another line from B, so one vertical line up to the reference line, and indicate the terminals. Dear students, don't confuse the different authors may be represent the different letters. So these all letters are arbitrarily. As per your convenience, you can keep it X, Y, Z or something, M1, O, P, Q or A, B, C, D. Everything, whatever the you require, just you keep the the letters only single time. Now I draw the one line, that is from the BG. Okay, so I can write the BG line, that indicates that. So what is the total motor? So here B to G, that indicates that total losses occurred in our induction motor. Okay, I drawn the BG line from the B point. So, I am going to get it that value. Okay. So, now here what is happened? So, here distance you can see this is a total losses. So, that is a total motor. Here what is happened? F and G is the core losses. Okay. What we are seeing here? Now, you can the BG is equal total output left the total losses. That is the work performance. Okay. What is that is equal to core losses, okay, core losses plus copper losses. Okay, copper losses. Here BG is now here B to F, that is the core losses. What is the FG? This is the core losses, the fixed losses plus and copper losses B to F. Now we know that copper losses are two types. Copper losses two. One is the copper losses is equal to here the rotor copper losses and the stator copper losses. Okay, stator having the winding, stator copper loss plus rotor copper loss. Okay, so I want to divide the stator copper loss and the rotor copper loss. Okay, then so what is happened? So under block rotor conditions at rated voltage, the power input is equal to the BG. That is the whatever the power is used, that is consumed in the form of losses. Okay, what are the losses? The fixed losses and copper losses. Now the fixed losses is the FG, that is maybe the under a block rotor test mechanical losses are 0. Okay, rotor is under standstill condition. What are the remaining? That is the iron losses. At iron losses under standstill condition, whatever the E2 is the S is equal to 1 and some losses may be occurred, iron losses that may be nearly more and slip is equal to 1, and at the same time remaining are the copper losses in the form of heat energy. So now I want to know that what is the rotor copper losses, what is the stator copper losses. Now in this case, so that purpose I am going to divide the BF, that is the total copper losses, into two forms. One is the rotor copper losses and another is the stator copper losses. Okay. Now that purpose I want to locate one point that is equal E. Okay, location of E. So how to locate this one? So this location of I want to separate the stator copper losses and rotor copper losses, and that purpose I require the some basic idea on squirrel cage induction motor and slip ring induction motor. Okay, so how we are going to that one? So we will see it. Okay, now I want to look location of that thing. Sorry. Now what is happened here? Location of this one, take it. Location of E. So what we have seen from here, so this is a B and we taken that is the G. Okay, so now here I taken the F. So we know that this is a fixed losses. I want to know this one, and this is a copper losses. I want to required the E point is required. This is equal F. Okay, so this is known as the stator copper loss. This is known as the rotor copper loss. Okay, so how we are going to place this one? That is the location of E in the squirrel cage rotor and slip ring rotor. Okay, so as an electrical student, I want to know details in this one. Okay, how to separate that one? In cage rotor, first we take the cage rotor, the squirrel cage rotor. squirrel cage rotor induction motor. So, how to know that? So, under black rotor test, input to the motor approximately equal to the copper losses only, because mechanical losses are 0 and iron losses are very less. Okay. So, whatever the short circuit condition, so short circuit black rotor test, whatever the WSC the records, that equal to the total copper losses. Okay, total we are assuming copper loss. Okay, then what is happened here, sir? Whether it is the what about the fixed losses? The fixed losses, iron losses. What is the fixed losses here? So mechanical losses plus iron losses. Here what is the mechanical loss? It is blocked. So rotor speed is 0. It is becomes the 0. And iron losses are very less as compared to the copper losses. Okay, so very less. That's why we are neglecting these iron losses also. So that means whatever the wattmeter shown during the short circuit black rotor test on an induction motor, so that we are assumed as a total copper losses. Now this total copper losses, I want to know that what is the stator copper losses, what is the rotor copper losses. I want to separate the assets to the two brothers. Okay, so the stator and rotor. So we know that stator copper losses. So we know that we taken the stator copper loss is equal to, so total copper loss, a 3-phase supply, I square. So that is the, we can see that is called stator, and I square, that is the SC, and this is equal R1. I square R losses. Okay. So this is a formula, but we know the stator copper loss. So what is a rotor? I want this is the total losses. I know this value, and this I1. Okay, so I know the I1. So we know the current value. We know the R1 I required. Okay, this is a something. Okay. So you know this value and this value. So you calculate this value because R1. How we are going to find the R1? So we know that VI method. So we are applying the some 10 volts. We measure the current. For example, 0.2 amperes. What is the resistance? Resistance is equal to V by I. So this VI method, I found the what is the value of this one. Okay. So that is the resistance 10 by 0.2. What is the value? 10 by 0.2 into 10. Okay. 2 ones are 2 5s are. That is equal to 50 ohms. I taken the average value. So from this one, I am going to get the R1. Already I know the ammeter reading. So from this, I am going to calculate this total, this one. Okay, I want the total. This is equal total copper losses. Okay, so here the stator copper losses, that is equal stator copper losses. We know that, and from the wattmeter, what is this value? Total copper losses minus stator copper losses. Okay, what is this one? From the meters, this is equal 3 I square SC R1. I know this. So I am going to get this rotor copper loss. Dear student, don't confuse it. Here the short circuit conditions, black rotors, I am going to get this is the power. Okay. So whatever the wattmeters will show the W2 wattmeter means W1 plus W2 is equal total power. This is just we are assumed as a total copper losses. From the total copper losses, okay, and I know the stator resistance by using the VI method. I know the stator current. From that I am going to calculate what is the stator copper losses. So total losses minus stator copper loss, I am going to the rotor copper losses. So based on these losses, I know what is the value? The stator copper loss and rotor copper loss. So, I can divide this one. So, what is the value? B and E, and this is the F. So, this indicates the stator losses, that indicates the rotor copper loss. So, based on this proportionate, I am going to locate the E point in case of squirrel cage induction motor. Okay. So, now coming to the wound rotor, similar to the wound rotor. So, here wound rotor, what is the wound rotor? Here, so R1 and R2 are stator and rotor resistances, because rotor also having the winding. So, now we are going to insert some resistance external also, but in case of the short circuit testers, we have the remove the external resistance. Okay. Now, we connect the star, whereas the I1 and I2 are the stator current and rotor currents. We know this all values. So, stator resistance and rotor resistance and stator current and rotor current we know. So, from this one I am going to get the rotor copper loss by stator copper loss. So, what is the value? Here I am going to that, so value that is equal to from B E by and E F. Okay. So, the line, so what are the line? We take in that one. We know that what is the rotor copper losses? We know that formula I2 R2, resistance we know, and I know the I1 R1. So, you know the resistance, you know the currents. So, you are going to get it. So, value, what is the value here? So, R2 by R1. Okay. So, into here what is the I2 by I1, that is equal to transformation ratio. Okay. So, that is the transformation ratio, you are going to get it. So, here I am going to get it R2 by R1 into K square. So, you know that R1 you know, and R1 already you calculated from the VI method. You know the transformation ratio, because what is the transformation ratio? We know that that is equal to V2 by V1 and N2 by N1, and there is a I1 by I2. We know that all things. Okay. E2 by E1 also, and I2. So, from this you know the K, and all R1 also you calculated by VI method, the R2 is don't know. So, you are going to calculate this value. Okay. So, you are going to get it. So, based on this one, so simply, so what is the final? So, we can write it rotor copper loss by stator copper loss, that is equal to R2 by K square and R1, that is equal, you can write it BE by EF. Okay. Such a way that you can going to locate the E point. Okay. So, based on this one, so we are going to locate that one. Let us see our class. Now, so you know in this case you calculated this location of this point. Okay. So, how to locate in squirrel cage rotor and how to locate wound rotor, we know that. So, after knowing this one, so join the A and E line. Now, join the E line. So, AE indicates that indicates that the torque line. Okay. So, AB indicates that the output line, and AE indicates the torque line, whatever the under short circuit condition given, that is equal to the total that one. Okay. This is the torque line, AE is the torque line. Now, after this line, so I am going to locate the point P, another P. So, how to locate that one? So, this is a simple circuit diagram, already we have seen in previous classes. Now take the B and some extension BL, you take it the some distance BL. What is the BL? Here, so what is happened? So I am going to draw the some BL. So here the BL indicates that, so you know the motor output is given. For example, 5 HP motor is given. Okay, the 5 HP motor is given. Now 5 HP meter converted into watts. So what is called 1 HP is equal to 745.5 watts. So based on you are going to convert this scale. Now here you measure the what is the B to G length. So from this length, so you are going to already WSN your calculated. Okay, so WSN you are calculated. So based on the power scale, you are going to convert this power into length. Okay, so what is the WSN? Already we know that root 3 ISN and V into cos phi. Yes, sir. You know that root 3 we know, ISN we calculated the normal. If you are applied the normal voltage, what is the short circuit current converted? Already you know the current scale, and you know the V rated voltage, and you know the this is a cos phi S. Then we are going to this value. So from this one, so you are going to get that some power. Okay, that power is equal, you convert 1 centimeter is equal to this power scale, you are going to get it power scale. Based on this power scale, divide the total output value, then you are going to get the length. So that you take that length from B to L. Okay, don't confuse it, dear students. So what is happened here? So first you take the this B to this value B to L. Sorry, take the here L. So extend this line BL. Thus BL is the taken from the output of the motor. Okay, so the output converted into the power scale. That power scale, whatever the value is given, for example 3 centimeters is given, then from this to this 3 centimeters, write it. Okay, now draw the one line parallel to the output line. What is the output line here? AB. Draw the one output line here, just like. Okay, then you are going to cut it here, so that it indicate the P value, P point. Okay, so this P point I am going to get it. So from 0 to P, that indicates that load current IL at that full load value. Okay, so I want to know the P value. How to know the P value? So extend the BG line up to the L with the help of motor output rating. That motor output converted to the power, and the power is divided to the power scale, and from the power scale you extend the length magnitude so parallel to the y axis, and after magnitude of this BL, draw one line parallel with the AB output line. This output line touches two places. So due to the slip is very low at the initially, so that is why you just take the P in this corner. So P is the located, then join the OP is the full load current value. If you measure the length OP, what is the distance, you convert the current scale, then you are going to get the what is the full load current at that condition. Okay, now after knowing the OP, then you draw the one vertical and parallel to the y axis. From P point you draw on the one line. Okay, now then what is happened? Now we can see it. Okay, so just you see the draw the line, and from that you draw the one line, that is a P, and now is a P, M, N, J, K, that is the points. So these are connected at different places. Okay, so M is connected at the output line, N is connected to the torque line, J is the the baseline and K is the reference line. Okay. So, here just the distance as a changes, please note it. Okay. M now join the OP. Okay. What is the OP? OP is the rated current. Now, after knowing this thing, so I want to know that, so this is a current. Okay. So, from this one P, that's a PM, that is the distance from the P to the output line, PM, that indicates the motor, the whatever the motor output value. Okay. Then P, here you are going to take that, so torque line up to this torque line, Pn is a torque line. So, you taken that is a value. Okay. The here the PM is equal to the output, and P here K total value is indicates the input value, input to the motor, and here J K indicates the fixed losses, and Mn, so that is the rotor copper losses, and N and J indicates the stator copper losses. Okay. So, these are the different points we can easily remember. What is the value? Total input is called Pk, that is equal total all values. P, length of the distance Pk, what is the distance? That indicates the total input to the motor, and length of the Pm, that is from P point to output line M, that indicates that the total output of the motor. Now, if you know the input, if you know the output, we can easily calculate what is the efficiency. The efficiency is equal output by input. So, that is equal, simply we can write it, the Pk, what is the output here? The Pk is the input, and so we are going to that write it the output by input. So, then we are going to the Pm by the Pk is the efficiency. Okay. So, here what is happen? Pk is the input, Pm is the output. Output by input is equal. So, we are going to get the efficiency into 100, we are going to get that. Okay. So, how can it is a very simple measure the length. What is the length? Pk, that is the input. What is the Pm? That is the from P point to the output line. Okay. You can see the red line. Okay. Here red line, that is a Pm. So, it measure the length. Now, what is the output? Output is equal to Pm. What is the input? That is equal to Pk into 100, we are going to efficiency. Now, suppose I want to know the full load slip. So, full load slip, already we know that rotor input is equal to the rotor input into slip times, we are going to get the rotor copper losses. So, rotor copper losses, I can easily find that rotor input into slip times. Same formula we are going to apply it. So, full load slip S is equal rotor copper loss by rotor input. Here what is the rotor input? That is nothing but Pn, that is called the output line. Okay. This is a pink line, you can see it, N, Pn. Okay. So, Pn. So, Pn is the rotor input. Okay. Rotor copper losses, already we know that. So, Be, that equal to what is the here? That is equal to Mn. So, now here S is equal to the full load slip, S is equal rotor copper loss by rotor input, that is called Mn by Pn. I am going to get the slip. Now, if you know the slip, I can easily calculate what is the rated speed N. N is equal to 1 minus S into Ns. I am going to get the rotor speed. Okay. So, dear students, so we can easily calculate it what are these values. Okay. So, do not confuse here. So, what is happen here? The Pk, what is the P? You can see it from. So, Pk indicates that motor input. Okay, motor input, and here Pm indicates the output. Okay. Next, and Jk, you can see the Jk indicates the fixed losses, and Mn indicates the rotor copper loss, and Nj indicates the stator copper loss. Okay. This is all we know that. At the same time, rotor input rotor, we can say, we can write the Pn is equal rotor input, that is equal P2 in case of my calculations. Okay, so you know that rotor copper loss, we know that P2 you know, the P2 is equal, so here rotor copper loss is equal S into P2. So I know the rotor copper loss, I know the P2, I can calculate the slip. What is the slip? The full load slip. Slip is equal to rotor copper loss by, okay, by rotor input. Okay, what is the rotor copper losses? M, N, and what is the rotor input? Pn. So from that I am going to get the S. If you know the S, I want to calculate the what is the N, the rotor speed, that is equal 1 minus S into Ns. Okay, Ns. So this is the formula. So these are the some few points. So we will see the remaining, the maximum torque and maximum output we will draw in next class, dear students. Please don't confuse, please listen carefully and do the practice. Okay, if you are having any doubts, we will clear in the next class. Okay, thank you for listening my class.